The morning of November 3rd, 1943, off the coast of Rabaul in the Bismarck Archipelago, Lieutenant Commander George Street stood in the conning tower of the submarine Tirante, watching through his periscope as a Japanese destroyer made its final turn into what should have been a safe anchorage. Street had stalked this target for 6 hours through waters thick with enemy patrol craft, maneuvering his boat into perfect firing position at just under 1,000 yards. He fired 4 Mark 14 torpedoes in a carefully calculated spread, 4 weapons that 18 months earlier would have been useless, their warheads failing to detonate, their depth mechanisms running them harmlessly beneath their target, their magnetic exploders triggering prematurely or not at all. But these torpedoes were different. These had been built after American engineers finally acknowledged what submarine commanders had been screaming about since Pearl Harbor, that their primary weapon was fundamentally, catastrophically defective. 3 of Street's 4 torpedoes struck the destroyer squarely amidships. The explosions came in rapid succession. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Massive detonations that broke the destroyer's keel and sent her to the bottom in less than 4 minutes. Japanese naval intelligence officers analyzing the attack from recovered documents and survivor testimony noted something that should have been routine but had become extraordinary. American torpedoes were working, not occasionally, not with the sporadic unreliability that had characterized every American submarine attack through mid-1943, but consistently, devastatingly, exactly as their specifications promised they would. What Japanese intelligence failed to understand until far too late was that this transformation represented not just improved weapons, but the unleashing of the most effective submarine campaign in naval warfare history. The mathematical certainty of Japan's defeat was being written in torpedo explosions across the Pacific, and the Japanese Navy's fundamental assumptions about the American submarine threat were about to be exposed as catastrophically, fatally wrong. The story of how American torpedoes went from being a laughingstock to an instrument of national annihilation begins not with engineering triumph, but with bureaucratic obstinacy so profound it bordered on criminal negligence. Throughout 1941 and 1942, American submarine commanders filed report after furious report, documenting failures that should have been impossible for weapons that had supposedly been tested and perfected before the war. The Mark 14 torpedo suffered from 3 separate catastrophic defects, each one bad enough to cripple the weapon's effectiveness, and each one masking the others in ways that made diagnosis extraordinarily difficult. Commander Dudley Morton, who would become one of the Navy's most celebrated submarine skippers before his death in combat in October 1943, wrote in a patrol report from February 1942 that he had fired 8 torpedoes at a Japanese transport from point-blank range and achieved 0 hits, 0 explosions, 0 damage. He observed through his periscope as torpedo after torpedo passed directly beneath the stationary target, running at least 10 feet deeper than their set depth. Morton's report concluded with language that barely concealed his rage. The Mark 14 torpedo is worthless. It will not hit targets even under perfect conditions. Either fix it immediately or give us weapons that work. The Bureau of Ordnance, the Navy organization responsible for torpedo development and procurement, responded with a message suggesting that Morton needed additional training in proper torpedo maintenance and attack procedures. This pattern, submarine commanders reporting obvious defects and the Bureau dismissing their complaints as operator error, would continue for nearly 2 years. While Japanese merchant ships steamed safely through waters that should have been graveyards, the 3 defects worked together in a way that seemed almost designed to prevent discovery. First, the torpedo ran approximately 11 feet deeper than its set depth due to a poorly designed hydrostatic depth control mechanism that had never been properly tested with the combat warhead. Second, the magnetic influence exploder, designed to detonate the torpedo beneath a ship's keel, was wildly unreliable, sometimes exploding prematurely, and sometimes failing to detonate at all. Third, even when the first 2 problems were corrected, the contact exploder itself was defective. At the high impact velocities characteristic of the Mark 14, the firing pin would bind in its housing during the sudden deceleration of striking a steel hull, preventing detonation. Japanese intelligence officers monitoring American submarine operations through signals, intercepts, and interrogation of captured submariners compiled detailed reports on these failures. The assessments that reached Imperial Naval General Headquarters in Tokyo painted a picture of American technological inadequacy that seemed to confirm Japan's superiority. American submarines, the reports concluded, were equipped with primitive torpedoes that didn't work. American submariners were poorly trained and lacked the aggressive fighting spirit necessary for effective combat. The vaunted American industrial machine was producing weapons that failed catastrophically under combat conditions. This assessment, based on accurate observation of American failures, but catastrophically wrong in its interpretation of what those failures meant, shaped Japanese strategic decisions about resource allocation and anti-submarine warfare doctrine in ways that would prove fatal. Throughout 1942, Japanese merchant ships operated with minimal escort protection. Destroyer escorts and patrol craft were allocated primarily to protecting naval task forces rather than cargo convoys. Anti-submarine warfare doctrine remained underdeveloped because intelligence assessments insisted submarines weren't a serious threat. Japanese naval construction priorities focused on battleships and carriers for the decisive fleet engagement that doctrine anticipated, not on unglamorous escort vessels for convoy protection. The merchant fleet carrying oil from the Dutch East Indies, raw materials from Southeast Asia, and finished military equipment to forward bases operated under the assumption that American submarines were an annoyance, not an existential threat. The numbers from 1942 tell the story of this mutual misunderstanding. American submarines in the Pacific fired 1,442 torpedoes that year. They claimed to have sunk 211 ships, totaling nearly 1.3 million tons. Post-war analysis of Japanese records revealed the true figures were 109 ships totaling 418,000 tons, barely 30% of claimed tonnage. Submarine commanders who had executed perfect attacks under impossible conditions, who had risked their boats and crews to get into ideal firing positions, watched in anguish as torpedo after torpedo either missed, exploded prematurely, or struck targets directly and failed to detonate. The morale cost was devastating. These men had trained for years to become submarine warriors. They took their boats into combat, knowing that submarines suffered the highest casualty rate of any American service branch, and their primary weapon was betraying them. Japanese merchant captains began reporting American torpedoes lodged unexploded in their hulls. These weapons were carefully extracted by Japanese ordnance personnel and examined with professional interest. The torpedoes revealed exactly what American submarine commanders had been reporting: catastrophic design flaws that made them unreliable at best. Japanese engineers noted the depth control problems, the overly sensitive magnetic exploder, the contact mechanism that frequently failed to fire. These examinations reinforced confidence that the American submarine threat was manageable, that Japan's merchant fleet could continue operations without the massive investment in convoy escorts and anti-submarine measures that would have diverted resources from offensive operations. The breaking point came in July 1943, with an incident so definitive that even the Bureau of Ordnance could no longer deny reality. Lieutenant Commander Lawrence Daspit, commanding the submarine Tinosa on her second war patrol, encountered the whale factory ship Tonen Maru, No. 3, south of Truk. The ship was enormous, 19,250 tons, alone and unescorted. Daspit fired 4 torpedoes and observed 2 hits that stopped the ship dead in the water. He immediately fired 2 more torpedoes. Both hit. 6 torpedo hits should have been more than sufficient to sink any merchant vessel, but Tonen Maru No. 3 remained afloat. With no enemy forces in the area, Daspit had time. He carefully maneuvered Tinosa into a textbook position, 875 yards directly abeam of the target, and fired 9 more torpedoes. He watched through his periscope as all 9 struck the stationary ship squarely at the optimal 90-degree angle. Not one exploded. Daspit heard the dull thuds of metal striking metal through his submarine's hull. 15 torpedoes fired under perfect conditions. 15 hits observed. 6 explosions. 9 duds. Daspit kept his last torpedo unfired for analysis and cleared the area. His patrol report was a controlled experiment conducted under combat conditions that proved conclusively the contact exploder was fundamentally defective. Rear Admiral Charles Lockwood, Commander Submarines Pacific Fleet, ordered immediate testing. His staff dropped dummy in warheads from a pier crane onto steel plates at various angles. The tests revealed that the firing pin mechanism bound at high impact velocities, particularly at 90-degree impacts. Direct hits, the perfect shot submarine commanders were trained to take, generated such sudden deceleration that the firing pin couldn't move fast enough to strike the detonator. The solution came from an unexpected source. Engineers examining Japanese aircraft shot down during the Pearl Harbor attack discovered the propeller blades were made from lightweight aluminum alloy instead of steel. This suggested making the torpedo firing pin from aluminum instead of steel, reducing its inertia during impact. Tests confirmed the theory worked. By September 1943, 21 months after Pearl Harbor, modified torpedoes with aluminum firing pins began reaching submarines. Combined with earlier fixes to the depth control mechanism and the permanent deactivation of the troublesome magnetic exploder, the Mark XIV finally became the weapon it had been designed to be. The transformation in American submarine effectiveness was immediate and catastrophic for Japan. Japanese naval intelligence began receiving reports in late 1943 of dramatically increased American torpedo effectiveness. Merchant ships that had been arriving in port with unexploded American torpedoes in their hulls were now exploding and sinking. Convoy after convoy reported successful American attacks. Ships were going down faster than Japanese shipyards could replace them. Japanese destroyer captains who had spent early 1943 hunting submarines with confidence born of their targets' weapon failures suddenly found themselves escorting convoys through waters where every shadow might hide death. The psychology of anti-submarine warfare had inverted. Previously, Japanese escort commanders had known that even if an American submarine achieved a perfect firing position, there was a good chance the torpedoes would malfunction. That knowledge allowed aggressive counterattacks and relatively casual convoy protection. Now, every American submarine represented a near-certain kill if it reached firing position. The escort doctrine that had seemed adequate when American torpedoes were unreliable became obviously insufficient when those torpedoes started working. On December 4, 1943, the submarine Sailfish, commanded by Commander Robert Ward, intercepted a small Japanese convoy east of Honshu. The convoy consisted of 3 merchantmen escorted by a single destroyer. Ward maneuvered into attack position and fired 6 torpedoes at the largest transport. 5 struck home. The transport, a 7,000-ton cargo vessel carrying aircraft parts and electronics equipment to forward bases, exploded and sank in less than 8 minutes. Ward immediately targeted the second ship, firing 4 torpedoes. 3 hit. The second transport went down bow first, her stern rising almost vertically before she slipped beneath the surface. The destroyer, detecting Sailfish's position from the torpedo wakes, charged in for a depth charge attack. But Ward had already gone deep, and the destroyer's ancient sonar couldn't maintain contact. The third merchantman, its crew panicking, broke formation and ran. Ward surfaced after dark, pursued on the surface using his superior speed, and put 2 torpedoes into the fleeing ship at dawn. 3 ships sunk in less than 12 hours. It was a pattern that would repeat itself thousands of times across the Pacific over the following 2 years. Japanese intelligence officers, analyzing the Sailfish attack and dozens of similar actions in late 1943, finally began to understand that something fundamental had changed. American torpedoes were no longer the flawed weapons of early 1942. They were working with devastating consistency. But this realization came far too late to implement the countermeasures that might have mitigated the damage. By the time Japanese Naval Command understood the magnitude of the submarine threat, the resources needed to counter it, destroyer escorts, patrol aircraft, sonar equipment, trained anti-submarine crews, were simply unavailable. Japan's industrial capacity was already stretched beyond breaking supporting offensive operations and replacing combat losses in the island campaigns. There was nothing left for a comprehensive convoy protection system. The statistics from 1944 document the collapse of Japanese maritime logistics. American submarines fired 6,920 torpedoes that year and sank 492 ships, totaling 2,388,000 tons. The effectiveness improvement over 1942 was roughly tenfold. For every torpedo fired, Japan lost nearly 350 tons of shipping. Oil tankers bringing crude from the Dutch East Indies were priority targets. American submarines sank them faster than they could complete round trips. By January 1945, Japan's petroleum imports had declined to barely 15% of 1941 levels. Steel mills shut down for lack of coking coal and iron ore. Aircraft factories stopped producing for lack of aluminum. Training programs for pilots ground to a halt for lack of aviation fuel. Naval vessels sat pierside, unable to sortie because there wasn't enough oil to fuel them. The combined fleet, once the third largest navy in the world, was reduced to immobility. Army divisions in China, Southeast Asia, and the Pacific Islands withered from lack of supply. Ammunition, weapons, medical supplies, food, everything had to be shipped from Japan, and increasingly those ships never arrived. Japanese garrisons went months without resupply as submarines intercepted the convoys that were their lifeline. On November 21, 1944, the submarine, Seleon, commanded by Commander Eli Reich, achieved what many considered impossible. Reich intercepted a Japanese task force transiting from Brunei to Japan and identified the battleship Kongo among the escorts. Kongo was a fast battleship, one of Japan's most valuable capital ships, escorted by 3 destroyers in waters considered relatively safe. Reich maneuvered Seleon into firing position at just over 3,000 yards and fired 6 torpedoes. 3 struck Kongo on her starboard side. The explosions opened massive holes below her waterline, flooding her forward magazines and engine rooms. Kongo lost power and began taking on water at a catastrophic rate. Her escorts attempted to take her in tow, but the damage was too severe. 3 hours after the torpedo hits, Kongo's forward magazines detonated in a massive secondary explosion. The battleship broke in half and sank, taking 1,250 of her crew of 2,300 with her. It was the only battleship sunk by American submarines in World War II, and it demonstrated that even Japan's most powerful warships were vulnerable to submarine attack when torpedoes functioned as designed. The human cost of the submarine campaign remains difficult to quantify, but was certainly catastrophic for Japan. Japanese merchant sailors died by the thousands, trapped below decks as torpedoes blasted holes in hulls, drowning in oil-filled waters, dying of exposure in lifeboats that drifted without rescue. The Imperial Japanese Navy maintained no effective rescue service for merchant sailors, viewing them as expendable civilian personnel. Many ships went down so quickly that crew had no time to launch lifeboats. Others sank slowly enough that men escaped into the water, only to spend days or weeks drifting before succumbing to exposure, dehydration, or shark attacks. The psychological impact on surviving merchant sailors was severe. Men who had witnessed ship after ship exploding and sinking knew their chances of surviving multiple voyages were minimal. By early 1945, Japanese merchant marine recruitment had become nearly impossible. Experienced sailors refused new assignments. New recruits deserted before their ships sailed. The government resorted to drafting sailors and posting armed guards on merchant vessels to prevent mass desertion. Ships that did sail operated under conditions of constant terror, their crews knowing that American submarines controlled the sea lanes and that every voyage might be their last. Japanese destroyer captains charged with escort duties faced an impossible mission. Their vessels, designed primarily for fleet actions and torpedo attacks against enemy warships, were poorly suited for anti-submarine work. Most destroyers lacked effective sonar. Depth charge equipment was often obsolete. Tactical doctrine for hunting submarines remained primitive compared to Allied methods. Commander Tameichi Hara, who survived the war as one of Japan's most experienced destroyer captains, wrote in his memoirs about the frustration of escorting convoys through waters thick with American submarines. "We could hear them on our hydrophones," he wrote, faint propeller sounds that indicated submarines pacing the convoy just beyond our detection range. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. We would drop depth charges and sometimes see oil slicks that suggested a kill, but most times we knew the submarine had simply moved away, waiting for darkness or a moment of inattention to attack. Our escorts were inadequate. Our equipment was obsolete. We were trying to protect shipping with tools designed for a different kind of war. The Battle of Leyte Gulf in October 1944 demonstrated how completely the submarine campaign had altered the strategic balance. On October 23, 1944, as Admiral Kurita's center force approached the Philippines through Palawan Passage, the submarines Data and Dace intercepted the column. Data, commanded by Commander David McClintock, fired 6 torpedoes at the heavy cruiser Otago, Admiral Kurita's flagship. 4 hit. The explosions tore huge holes in Otago's hull. She lost all power and began sinking rapidly. Otago went down in 28 minutes, taking 360 of her crew with her. Data immediately shifted targets, firing 4 torpedoes at the heavy cruiser Takao. All 4 hit, crippling Takao so severely she had to withdraw from the battle. Dace, firing from the opposite side of the column, targeted the heavy cruiser Maya. Multiple torpedoes hit, breaking Maya's keel and detonating her magazines. Maya broke in half and sank in 8 minutes, killing 769 of her crew. In 30 minutes, 2 American submarines had sunk 2 heavy cruisers, crippled a third, and left the commander of the Japanese center force without a flagship at the opening of the largest naval battle in history. The submarines had struck first, disrupting Japanese command and control before the main forces even engaged. Whether Admiral Kurita's subsequent hesitant performance at Leyte Gulf was influenced by this attack is unknowable, but the loss of his staff and communications equipment certainly didn't help his decision-making during the critical battle that followed. By January 1945, Japan's merchant marine had been reduced to roughly 1/4 of its December 1941 strength. American submarines were sinking ships faster than Japanese shipyards could build them, even if those shipyards had possessed adequate steel, workers, and power, which increasingly they didn't. The mathematics were brutally simple. Japan required approximately 3 million tons of merchant shipping to maintain minimum imports of food, oil, and raw materials necessary to continue the war. By March 1945, available merchant tonnage had fallen below 1 million tons. The economic foundation of Japan's war effort had collapsed. Oil refineries shut down for lack of crude. Steel production ceased for lack of iron ore. Food imports declined to starvation levels. The home islands faced famine. American strategic bombing, which received enormous attention in post-war assessments, was actually secondary to the submarine blockade in destroying Japan's ability to wage war. Factories couldn't operate without raw materials, regardless of whether they were being bombed. The Army Air Force's firebombing campaign devastated civilian populations and destroyed urban infrastructure, but Japan's war economy had already been strangled by submarines cutting the maritime supply lines that island nations require for survival. The atomic bombs dropped on Hiroshima and Nagasaki on August 6 and 9, 1945, provided the Japanese government with a face-saving reason to surrender. But Japan was already defeated economically by that point. The nation couldn't continue fighting regardless of its army's battlefield performance because submarines had destroyed the logistics system that sustained those armies. The final accounting of the American submarine campaign reveals its decisive impact. American submarines sank 1,178 Japanese merchant vessels, totaling 5,503,000 tons, representing 54.6% of all Japanese merchant shipping losses from all causes. They also sank 201 naval vessels, including the aircraft carrier Shinano, the largest carrier ever built at 72,000 tons. This was achieved by a force that never numbered more than about 100 boats on patrol simultaneously, representing less than 2% of US Navy personnel. The return on investment was extraordinary. For every submariner who died in action, the submarine force sank approximately 540 tons of enemy shipping and killed roughly 100 enemy sailors or soldiers who died when their transport ships were torpedoed. The transformation from the failures of 1942 to the devastating effectiveness of 1944 and 1945 stands as one of the most dramatic capability shifts in military history. What changed wasn't tactics or courage or training, though all improved over time. What changed was that American engineers finally fixed the torpedoes, and once they did, submarine commanders who had learned their trade in the unforgiving school of combat could employ weapons that actually worked. The Japanese assessment that American torpedoes were primitively flawed had been accurate in 1942, but Japanese intelligence failed to understand that American failures were temporary technical problems that American engineering and industrial capacity would eventually solve. Japanese strategic planning made assumptions about the American submarine threat based on early war performance and failed to adjust those assumptions when the threat fundamentally changed. There is a broader lesson here about intelligence assessment and strategic planning. Observing your enemy's current failures and assuming those failures are permanent characteristics rather than temporary conditions is a mistake that nations make at their mortal peril. The Japanese looked at American torpedo failures in 1942 and saw evidence of fundamental American technological inadequacy. What they should have seen was a temporary setback in a nation with the industrial capacity and engineering talent to identify and fix any technical problem given time. That failure of imagination cost Japan its merchant marine, its war economy, and ultimately the war itself. By August 1945, when Emperor Hirohito announced Japan's surrender, the submarine campaign had already rendered continuation of the war economically impossible. The torpedoes that Japanese intelligence had mocked as defective in 1942 had become the instruments of Japan's economic strangulation by 1945. The destroyers that had escorted convoys with casual confidence in early war were by late war shepherding remnants of a shattered merchant fleet through waters they no longer controlled. The mathematical certainty of defeat had been written in the cold equations of tonnage sunk versus tonnage built, and those equations admitted no solution that didn't end with Japanese maritime collapse. The Mark 14 torpedo, once the most infamous failure in American naval history, had been transformed through engineering persistence into the most effective submarine weapon ever employed in combat, proving that in warfare, today's failures can become tomorrow's decisive weapons. If you have the industrial capacity and institutional will to identify problems, implement solutions, and give your warriors tools that work. The irony of the Mark 14's transformation extends beyond simple technical correction. What the Japanese had observed in 1942 was real. American torpedoes were catastrophically defective. Japanese merchant captains reporting unexploded American torpedoes lodged in their hulls weren't exaggerating. Japanese intelligence officers concluding that American weapons were flawed weren't making analytical errors. Every piece of evidence they collected pointed to the same conclusion that American submarine warfare was ineffective because American torpedoes didn't work. Where Japanese analysis failed was in understanding what that evidence meant for the future rather than just the present. The cultural dimension of this intelligence failure deserves examination. Japanese military doctrine emphasized fighting spirit and warrior ethos as decisive factors in combat. The assumption ran deep that superior will and training could overcome material disadvantages. When Japanese officers observed American torpedo failures, they interpreted those failures through a lens that said Americans lacked the discipline and dedication necessary for precision warfare. The Americans couldn't build reliable torpedoes because they lacked the attention to detail and craftsmanship that Japanese industry emphasized. This interpretation felt comfortable because it confirmed existing prejudices about American character and industrial culture. What this analysis missed entirely was the American approach to problem solving. American military culture, particularly in technical fields, emphasized systematic analysis and engineering iteration. When something didn't work, you tested it until you understood why, then you fixed it. The bureaucratic resistance from the Bureau of Ordnance was an aberration, not the norm, and once that resistance was overcome by undeniable evidence from combat, the fixes came relatively quickly. Japanese intelligence officers watching American torpedo performance should have asked not whether the Americans could fix their torpedoes, but how long it would take. That question would have led to very different strategic assessments. The missed opportunity for Japan was in the 18-month window between Pearl Harbor and September 1943, when American torpedoes were largely ineffective. During that period, Japanese merchant shipping operated with minimal protection because intelligence assessments said submarines weren't a serious threat. If Japan had instead assumed that American torpedo problems were temporary and would eventually be solved, they might have used that window to implement comprehensive convoy protection measures, build destroyer escorts in quantity, develop effective anti-submarine tactics, and train specialized crews for submarine hunting. These preparations, undertaken while American submarines were still struggling with defective weapons, might have created an anti-submarine warfare capability robust enough to limit the damage once American torpedoes began working properly. Instead, Japan spent 1942 and early 1943 building battleships and fleet carriers for the decisive engagement that never came, while the merchant fleet that sustained the entire war economy operated essentially unprotected. By the time Japanese Naval Command recognized the submarine threat's magnitude in late 1943, implementing effective countermeasures had become impossible. The resources simply weren't available, and the industrial capacity needed to build escort vessels in quantity had already been committed elsewhere or destroyed by American bombing. The human stories behind the statistics reveal the personal cost of Japan's intelligence failure. Lieutenant Haruki Ito, a destroyer captain who spent 1944 and 45 escorting convoys, kept a private journal that survived the war. His entries from early 1944 document a growing sense of helplessness as American submarine attacks increased in frequency and effectiveness. January 12, 1944. Lost another tanker today. The American submarine fired from perhaps 4,000 meters. 3 torpedoes, 3 hits. The tanker exploded and sank in minutes. We dropped depth charges but never made contact. Our sonar is inadequate. Our tactics are inadequate. We are shepherding ships to slaughter. By August 1944, Ito's entries had become darker. We departed Balikpapan with 7 ships. We arrived in Singapore with 3. 4 sunk by submarines in 5 days. The men ask me how to protect the convoys. I have no answer. Our equipment cannot detect submarines at the ranges they attack from. Our depth charges cannot reach the depths they dive to. We are fighting with obsolete weapons against an enemy who controls the sea. Ito survived the war, but his destroyer, by war's end, had escorted 43 convoys and watched 31 ships under his protection get torpedoed and sunk. The psychological toll on escort crews who repeatedly failed to protect their charges despite maximum effort was severe. The economic cascade of the submarine campaign accelerated throughout 1945. By March, oil imports had essentially ceased. The handful of tankers that still operated were hoarding fuel, unwilling to sortie because the chance of completing a voyage had become minimal. Japan's remaining aircraft carriers sat immobile, not because they lacked trained pilots, though they did, but because there wasn't fuel to operate them. The super battleship Yamato's final sortie in April 1945 for a suicide attack on American forces at Okinawa was fueled with oil scraped together from reserves scattered across multiple bases, barely enough for a one-way voyage. She never reached her target, sunk by carrier aircraft while still hundreds of miles from Okinawa. Food imports collapsed in parallel with oil. Japan had never been self-sufficient in food production, depending on rice from Korea and Southeast Asia to feed its population. By spring 1945, those imports had been cut to starvation levels by submarines, sinking cargo ships faster than they could be replaced. Urban populations faced genuine famine. Rice rations in Tokyo dropped to barely 800 calories per day, well below subsistence level. Black markets flourished but couldn't supply enough food for millions of city dwellers. The government requisitioned rice from rural areas, creating agricultural collapse and resentment. Malnutrition became widespread. Industrial workers weakened by hunger couldn't maintain production rates, even in factories that had raw materials, which increasingly they didn't. The submarine campaign's effectiveness in 1944 and 45 stands in stark contrast to German U-boat operations in the Atlantic. German submarines, operating with generally reliable torpedoes from the war's beginning, initially achieved devastating results against Allied shipping. But the Allies developed effective countermeasures: convoy systems, escort carrier, long-range patrol, aircraft, advanced sonar, code-breaking that revealed U-boat positions, all combined to turn the Battle of the Atlantic against Germany by mid-1943. German submarines went from predators to prey as Allied anti-submarine measures became increasingly sophisticated. By 1944, U-boat losses exceeded their ability to sink Allied shipping, and the campaign had effectively failed. American submarines in the Pacific faced no such reversal. Japanese anti-submarine measures never approached Allied effectiveness. Convoy protection remained inadequate throughout the war. Japanese sonar technology lagged years behind Allied equipment. Code-breaking, which so damaged German U-boats, worked in reverse in the Pacific, where American intelligence regularly read Japanese convoy routing messages and positioned submarines along intended tracks. Japanese escort carriers, the few that were built, were sunk or used for other purposes rather than anti-submarine patrol. Long-range patrol aircraft that might have hunted submarines were instead committed to other missions or destroyed in combat. The result was that American submarines operated with increasing freedom as the war progressed, rather than facing the escalating opposition that German U-boats encountered. The final months of the war saw American submarines running out of targets. By June 1945, Japanese merchant shipping had been reduced to such minimal levels that submarines on patrol sometimes found nothing to attack. The few Japanese ships still operating stayed in port during daylight, moved only at night through coastal waters, and employed routes so circuitous that voyage times tripled. Even these desperate measures often proved insufficient. Submarines equipped with radar could detect targets at night. They could wait off Japanese ports, knowing that any ship departing would have to pass through predictable channels. The sea lanes that had once carried Japan's industrial lifeblood had become graveyards where submarines hunted the remnants of a shattered merchant fleet. The Mark 14 torpedo's evolution from failure to triumph encapsulates a broader truth about industrial warfare. Technical problems, no matter how severe, can be overcome by nations with sufficient engineering talent, industrial capacity, and institutional will to identify and fix defects. The torpedo's three separate catastrophic flaws were eventually solved not through brilliant insights, but through methodical testing, honest assessment of results, and implementation of fixes. The aluminum firing pin that solved the contact exploder problem wasn't revolutionary technology. It was a simple material substitution that anyone could have tried if they'd been willing to admit the problem existed and test solutions systematically. Japan's failure was assuming that American problems were permanent characteristics rather than temporary setbacks. The defective torpedoes of 1942 became war-winning weapons by 1944, not through magic, but through American industrial culture's emphasis on identifying problems, testing solutions, and implementing fixes at scale. Japanese intelligence officers observing American failures should have asked themselves whether a nation that could build the Panama Canal, develop mass production techniques for automobiles, and create continent-spanning infrastructure would be permanently stymied by torpedo defects. The answer should have been obvious. America would fix the problems eventually, and when they did, the submarine campaign would become devastating. That recognition might have prompted very different strategic planning about convoy protection and anti-submarine warfare investment. Instead, Japan bet its survival on American torpedoes remaining defective, and lost that bet catastrophically. The price was paid in sunken ships, drowned sailors, starving civilians, and ultimately in national defeat. The destroyers that encountered Mark 14 torpedoes in late 1943 discovered too late that the weapons they'd dismissed as ineffective had become instruments of methodical annihilation, and by the time that recognition came, changing course had become impossible. The mathematics of tonnage sunk versus tonnage built admitted only one conclusion, and submarines firing reliable torpedoes had already written that conclusion in water across the Pacific. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.